Hey guys, good morning. How's it going? Now, I want to get into how we're going to use imaginary numbers and imaginary units for some things that we can actually do. But in order to get to our first example, which is to be using the discriminant, we have to have kind of a recap of quadratics, which we did much earlier in the year. Okay, so quadratics. First of all, quadratics are functions that have an x squared. Okay, so our basic form, okay, would be something like this: f of x equals ax squared plus bx plus c, right? And this was kind of in standard form, yes? So for a function, this is the standard form, okay? Where essentially we have three different elements. We have an x squared element, an x element, and then we have a constant. Okay. What we are going to be really focused on, hopefully you guys remember this, is what the coefficients are. Okay. So the coefficients we're looking for are going to be a, the number that comes in front of x squared, b, the number that comes in front of the x, and c, which is going to be the constant. So if I gave you something like this, f of x is equal to 5x squared plus 4x plus 3. Well, in that case, a is 5, b is 4, and c is 3. It's pretty straightforward. We just want the numbers that are here. There's a couple little wrenches they can throw in your plan. What if I said d of x is equal to x squared plus 2x plus 1? Well, in this case, a is actually 1. We don't write a 1 there, but it's definitely not 0. A is equal to 1, b is equal to 2, and c is equal to 1. So if you don't see a number in front of x squared or x, it's going to be 1. A couple other things that they can show you. What if I said this, x squared plus 3x? Well, in this case, a is 1, like we just said. B is 3, and there is no c. C is 0, okay? There is no c. What if I gave you, I don't know, h of x is equal to 47x squared plus 2x, I'm sorry, plus 2. Let's just say for that, okay? Well, in this case, a is 47. Now, this right here, this is c. With this case, we don't have a b, because remember, b has to have an x attached to it, okay? In this case, we don't have. We have 0, okay? And c is going to equal 2, okay? So just watch that when they skip things, okay? Remember, the x is the b term, okay? So whatever the coefficient for x is. And this one, sorry, I didn't have an x. There's an x squared and a constant, okay? All right, and these different things, they had different impacts on the graph, right? So again, not to go too far into things, but a essentially changed how steep the graph of the function was. Okay, it also changed whether it went up or down. Okay. Oops, wrong form, sorry. Okay, again, A changed how steep the graph was. B actually changed the location of the vertex, right? So if you actually, if I click on it, I'll show it to you guys. This point right here, if you watch, B is going to change the location of that. Right? And C just moved it up and down. So again, we'll talk about what that all means later. But A, B, and C had different impacts on the shape of the graph when we drew it. Okay? Now, what are we going to be most concerned about are what are called the roots. These 2 points right here, where this equation crosses over the x-axis. Okay? Now, why are we talking about this with imaginary numbers? Well, if we take a look at it, right here we have roots. You see there's two of them, right? There's two of them right here, right? They're going down. For a very split second here, you're going to have one, and then you're going to have none. There are no roots, or at least it appears that there's no roots. What we can use imaginary numbers for is we can actually say there are roots, but they don't exist here. Okay, they're not real numbers, therefore they don't appear here. So what we need to do is we need to use a formula that we haven't talked about in a while, and that is called the quadratic formula. I'm going to put it here, and you guys are going to hate me. Okay, quadratic formula. And the quadratic formula we use for solving equations, specifically when we're solving for the roots. And that is this: negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay? This is the formula that will give us either the answers if it's a quadratic equation or the roots if it's a quadratic function. Now, what are we concerned about? We've been talking about this, right? We've been talking about, hey, when is it not a real number? Well, therefore, the only thing we are concerned about for this thing is this guy right here. We are only care about this part. This is b squared minus 4ac. Okay? Essentially, if I evaluate this, if it is positive, I have two roots. Two real roots. If it is 0, I have one real root. And if it is negative, I have two non-real, or we can also put it 0 real roots. Okay, and again, that's because the number that comes out here is negative. We can't have a negative square root. So we'll talk about that tomorrow, okay? So we call this right here, what's underneath this square root, we call this b squared minus 4ac. We call this the discriminant. Discriminant. Okay, it's not to discriminate. This is not like the really bad part of math where we judge people. No, this is the discriminant. Okay, this is the discriminant, not discriminate. Discriminant. Okay, so it will allow us to choose between whether things have real roots or non-real roots. Okay, so this was your quick little recap. We'll get into the very specific stuff tomorrow. Thanks, guys.